everyone. Today we are going to talk about our Control System 1 project and it's called the Hawkeye. Now, what is Hawkeye? Hawkeye is a complex computer system used officially in numerous sports and it is used to visually track the trajectory of the ball and display a record of its statistically most likely path as a moving image. Now, let's have a glimpse of Hawkeye. This clip is recorded from ICC's official website and this over is from Bangladesh versus India match. It was also the motivation for our project.
Now let's talk about what we have done in this project. We have simulated Hawkeye using MATLAB Simulink 3D Animator. We have chosen VRealm Builder as our virtual reality modeling language editor. We have successfully simulated the trajectory of the ball considering ball speed, ball spin, directions, air drag, and pitch characteristics. Let's talk about the ball physics applied here. We can resolve the velocity of a ball, which is of course a 3D vector along the 3 axes. When a ball hits the ground, its velocity along y-axis is reversed and it goes up with a reduced velocity. This is called the damping effect. Also, the velocity along x and z-axis are damped by an appropriate damping factor. This is done to model the air drag. Let's see how it was done. At first, we create a new Simulink model. I guess all of you know basic schematics in Simulink, so I'm not going to show you the details. Well, the blocks I've drawn here are useless, so I'm basically going to delete all these. Go to the command window and type vr install dash install editor. This will install the VRML editor. Then go to the preferences and Simulink 3D animation and select VRM Builder as your VRML editor. The built-in 3D world editor is really tiresome and I do not recommend you to use this. Now let's double click on the VRSync block. It's a block which connects our Simulink model to our 3D world. If you double click on VRSync block, you can see this window. Click new to create a new model. You can see various options up there. You can draw your desired shape very easily simply by clicking and dragging. I'm going to draw some basic blocks for you. Here is a sphere. You can see various options on the left plane like center, rotation, scale, scale orientation, translation, and shape, appearance, materials, texture, texture transform, geometry, etc. You can control the position of the ball using translation. Now let's change the shape of the sphere. If you double click on the geometry and sphere, you will find an option called radius. You can edit the radius and change the shape of the sphere. You can draw the pitch by drawing a box really thin. If you change the y-axis measurements of the box, you will get a box really thin, and this will represent the pitch. This VR expander block is very important. We are setting output width as 3 and output signal indices as 1, 2 and 3. In order to keep this tutorial short, we are skipping all the drawings. You will get the files in the comment section. Here is the final model. A very important note on the VRSync block. There is a term called block parameters which bears the sampling time. We keep the sampling time small enough so that we can observe the animation slowly and carefully. On the right side, there is variable tree bearing various nodes. We can control different parts of our 3D world by selecting proper nodes. The nodes we are controlling are off stump, leg stump, middle stump, and the ball. If we want to control any node, we have to expand that node. For example, we will incline the stamps when hit by the ball. So we select rotation from here. In case of the ball, we select the ball translation. To know the details of the VRML editor, which is in our case VRML Builder, we read this PDF very carefully. You will get a clear idea about the process if you read this very carefully. Now let's have a look at our MATLAB function block. This code controls the ball physics. Here are the function parameters. This conditional segment describes the bouncing and damping mechanism. And this block is responsible for the physics of the storms. Now let's run our model. We have placed a scope in the y-axis measurements. Here is a plot of ball position versus time. You can clearly see the damping from here. Now we are going to check our model for different conditions. We will simulate a fast ball with bowling speed 135 km per hour, bowling angle -10 degree with the horizontal axis, and 0 spin speed, 0 transverse z axis speed. We tried our best to make the best possible animation, but still there are some scope for improvements. These include better designing of the 3D world, which implies better fields, stumps, pitch, realistic cricket ball. Better animation can be made. More parameters and environmental factors can be considered. Control using game controller or MATLAB graphical user interface is still possible. That's all for today. Thanks for watching.